8 minutes after 11, Tuesday morning. Gary King in for John this morning. And my guest now is Jane Green. She's Royle's astronomer normally, but today she's King's astronomer. Morning.
Good morning, Gary.
It's been a busy old day, well, last couple of days, hasn't it, for
Yes.
in the stars?
Yes,
a bit
it
further
has.
afield, though, Mars.
Yes.
This Curiosity lander.
Yeah.
Do you think it's going to work? Well, it obviously has worked because it's landed.
Yes, it's landed, which has been no easy task, actually. In fact, it's quite incredible to think that, well, it's not that small. I mean, it's about the size of a bus, actually, that it's made that enormous trek. It's taken 8 months to get there, and the technology that has been involved and the thousands of scientists that have worked together to make that happen is really quite phenomenal. The technology is, well, it's mind-blowing.
But 8 months doesn't seem that long. I mean, Mars is how many miles away? 250 million miles or something, wasn't it, they said?
567 million kilometres.
Kilometres.
So it's quite a trek.
Quite a trek.
And once it finally reached the atmosphere, the very thin atmosphere of Mars, it was actually travelling at Mach 24 times the speed of sound, which is pretty phenomenal in itself. And then it was concealed in a capsule with a protective ablative shield, they call it, to absorb all the gases whilst it's hurtling at that speed through the atmosphere. So this craft, all sort of, folded up within itself inside this capsule, just like the Apollo moon capsules, is hurtling through, well, approaching the atmosphere. As soon as it starts going through the atmosphere, it's burning off to protect the instruments inside. Then the base of the capsule is, there's an enormous parachute, I think something like 21 metres wide, is floating it down through the atmosphere. Then the bottom part of the capsule is blasted away, so the inside rover can then come out and extend its legs. And then whilst it's doing that, they have to sort of blast away certain amounts of ballast to make sure that it hits at just the right angle, approaches at just the right angle, and then the rocket jet to keep it at that angle to slow it down eventually. And then the actual craft itself is lowered on 3 cables that, they're quite rigid, lower it down to the surface, and then they are released, and what remains of the capsule is then jetted away, so it doesn't actually hit the rover, which is quite something in itself, isn't it? And then there it is, nicely settled down at something like 6:30 British summertime yesterday morning.
Yes, I was actually arrived at the studio and I saw someone Facebooking to say I'm watching it on NASA TV, so I quickly went to nasa.gov and saw just the aftermath of everyone at I think it was at Cape Canaveral, wasn't it? This was mission control for there.
Yeah.
In hysterics,
Yes.
in hysteria, celebrating because they really did think there was a possibility that he wasn't going to make it. It was just going to either crash and break into smithereens or burn on the atmosphere.
Yes, because although these things are tested phenomenally, there are still, like everything else, there are still so many things that can go wrong. Every part of that descent can go wrong. Even though it's tested, there's always that odd chance that it could. So the very fact that everything has worked so well is a testament to all the hard work, isn't it? The ingenuity and the intelligence behind it.
Now, this is going to. First of all, what is the purpose of this mission? What is NASA's real aim?
Well, there's a number of aims, really. To look back, so much work has been done by previous rovers. The Vikings, Spirit, Opportunity. And also those spacecraft that have been and still are in orbit around the red planet. They've been studying the terrain. They've been able to get down and look close up at that terrain. And all the evidence suggests that at some stage in Mars's past it was a good deal warmer than it is now. So they know that there is evidence for water. I mean, on the surface it's frozen, but much, much lower down there's evidence within the sort of residual clays that have been sedimented one on top of the other. It implies that there has been water at certain times in the history of Mars. So they want to find out why that is. They know now where the water is, so they've put Curiosity down in a crater where they can look a lot closer and actually dig down to see to find that water, and then drill to study it to find what chemicals are in it. And so by doing that, they hope to find examples of what happened to Mars, and possibly then how water did form and stay on our planet. So it's looking at analogies between the two planets, really, but mostly to look at the history of Mars. And of course, with a view to future exploration, because NASA's view, and indeed the view of many private companies now, is to get spacecraft to Mars, get men on Mars, exploring and possibly colonising it too.
Looking at the footage yesterday, they showed a few photos of it on the surface. But this mission is going to take, what, 2 years?
Yeah.
Are they going to be constantly sending photos? So we're actually going to see the land of Mars?
Yes.
Or are they going to be keeping this very much to themselves at NASA and then just give the findings in 2 years' time? Are we going to wait for 2 years to actually find out and look at more photos?
No, they're going to be, it'll be pretty much daily. I mean, there may not be that, so many things to report daily, but there's going to be a lot of information fed back, because it'll be constant telemetry. So they'll be analysing all the time, giving instructions all the time, waiting for the feedback from that, but releasing it, pretty much immediately.
And what's this cost, NASA, the Americans?
I think it's a couple of billion.
Couple of billion?
Yes.
So
yes.
Do you think this is making up for the space shuttle, for NASA, for sort of abandoning the space shuttle? They've given up with the space shuttle now, and they want to try and, as you say, put people on Mars. That's the next step. Do you think the space shuttle will come back in some form to get people to Mars?
Yes, I do, but possibly not through NASA. It's going privately. China and India are actively pushing to head towards Mars, especially India. So they're well on the way. That is their intention, to put men on Mars. But also, there's a great deal of competition now between private companies to get spacecraft orbiting Earth, which it already has been done. SpaceX has done that, but they want to get further and further afield. The view is to get further afield. So yeah, undoubtedly, ultimately, they will have men on Mars.
Now, did the British try this a mission to Mars a few years ago? Did that fail?
Yes, it did. Yes, the
Why
Beagle
was
lander. I'm not sure. I'm not sure why. I know that the orbiter, the Mars Express, was up there and stayed up there, but they put the Beagle lander itself, they lost communication with it for some reason. So, and I'm not sure what that reason was, but it was a matter of they lost communication.
As you, as someone who is a astronomer, interested in it as well, what do you hope comes from this Curiosity Mars landing in 2 years' time? What are you hoping they're going to find?
That's a good question. I'm not sure. I would like there to be confirmation of water lower down, which enables us to understand a great deal more about how Mars formed, why it lost that water, because the terrain does imply that there was a great deal of water, not just, rivulets here, floodplains, and in fact even seashores that implied there were oceans. We need to know, wouldn't it be great to know why those oceans disappeared, why Mars lost its atmosphere? Because by understanding that, we're going to understand a great deal more, and on a very personal level too, about our planet and how we should have probably better stewardship of our planet. So I hope that the results will guide us to take better care of the planet that we're on.
And we're not going to find any Martians, any weird creatures or anything like that, do you think?
How can I say no? Because you always have to be open to that. But
it's like the Loch Ness Monster.
Yes.
If they're going to have a camera up there, they'll find something. We'll take a break. We're going to talk about what's coming up this week. My guest this morning, Jane Green, Royals, but today's King's Astronomer. We've been talking about the Mars Curiosity Lander. Let's move on to something happening now. They're coming up this weekend. It's one of those, another meteor shower.
Yes.
How do they know it's going to happen this weekend? That's what I want to know.
Yeah,
or don't they know?
That's a good... Yes, no, they do know.
They do know.
They do know, yes. They know. And firstly, what is a meteor shower? Well, it's an increase in the number of shooting stars. So if any of the listeners are wondering, well, what is a shooting star? It's basically because when our star was formed and the planets were forming around it, they formed from this giant cloud that was full of dust and debris. That dust and debris built the sun, if you like. It built the planets, but it didn't sort of clear away completely. There's an awful lot of dust and debris still left surrounding our entire solar system. Of course, Earth is travelling around our sun throughout the year, and as it travels around, it passes through a lot of dirt and debris all the time. I mean, when you look up, you can see shooting stars quite regularly.
Yeah, at any time of the year.
Yes.
I mean, sometimes I'm sort of out in the garden late at night. This time of year it's fine, but not in bleak winter.
No.
But every so often you suddenly look up and you think, what's that actually? But it will just be one.
That's right.
Whereas with this one, which is the Perseids Meteor Shower, it's going to be over a longer period of time and constant, sort of once every minute.
There's going to be a lot more. Now, the predicted peak is 100 per minute. Now, the reason
100 per minute
could be. They say it could be 100 per minute.
Anywhere in the country, or in the world, I should say, or just in certain parts of the world.
No, anywhere in the world where you're in a position to be able to see it at that time.
Right.
Now, firstly, why is there an increase in the number of shooting stars? Well, that's because the star and the planets orbiting our sun are all in one particular plane. They call it the ecliptic, so it's like a flat plane and everything's circling around in the same level. But of course, what happens, because it's so messy out there are a lot of objects a lot further away, but they're still caught in the gravitational pull of our sun, and they are pulled towards our sun. And these are giant rocks or lumps of ice and dust, and better known as the comets. So these lumps of rock and ice, as they come towards the sun, they get hotter and hotter, and the heads of those, what they call the coma of those comets, burn away. And as the comet goes around the sun and travels back out again into the solar system and way beyond the solar system, they leave a trail of dirt and dust and debris behind them. So as Earth is travelling around the sun, at certain times of the year, it passes through the trail of these comets, which is quite incredible, isn't it, really, to think that some of these comets, some are short-period comets, which means they've taken less than 200 years to make a big loop around the sun and go out again. But other comets have come from much further out, and they can take thousands of years to pass around the sun and go back out again. But their trail, the tail of all the dirt and dust that's left, is still there, and we pass through that periodically throughout the year. So astronomers know that at least 10 times a year we pass through predictable tails, predictable bits of debris that have been left, and by studying that for years they're able to predict where that tail is. They know that we'll be passing through it, and there will be a lot more dust there. So the dust will then hit our atmosphere, and because there's a lot more of it, a lot more is burning up. So you see a lot more activity, especially after midnight, because of course as Earth is turning, as it's rotating, we're behind the forward motion of our planet until midnight, when we start turning and we're moving, but we are positioned head on. So we're hitting a lot more debris, so you're able to see a lot more, and there is a lot more activity. And this is why we get peak, what they call zenithal hourly rates, peak rates of shooting stars. We're just hitting a lot more dust at that particular time in our orbit around the star.
And you can see all this with your normal eyesight, naked eye. There's no need to. You can see as many as if you have a telescope. Or would you see more if you had a telescope?
No, you wouldn't. In fact, it's recommended don't look,
because you don't know where they're going to appear.
No, you don't. You know that they appear from what they call a radiant. So they come from the constellation of Perseus. So you need to look in that direction.
Which is which direction?
Which is north. Looking northeast,
right.
And you need to be looking at about a good 60 degrees up, so at that sort of angle.
That's good, because this weekend I'm going away. I'm going away for a week. I'm going to Norfolk. I'm going to the Norfolk coast at Cromer, right by the beach.
Beautiful.
Going out to the North Sea. So all I've basically got to do is look out towards the North Sea. And look up.
Yes.
And I'm just going to see a great show. But what sort of you're saying after midnight? Any particular time?
After 1 o'clock in the morning is the best. But you're going to see an increase anyway, because the thing is that the peak time when astronomers predict that most activity will take place is actually around lunchtime on Sunday. So you won't see it. But there is still always increased activity before that time and after. In fact, for days. So you're going to see many more shooting stars anyway. The only thing that we have to contend with is that we do have a waning moon. So the moon will be up there, and the moon does throw quite a lot of light pollution. It rises about 1 in the morning, so you'll get some light pollution. But even so, the Perseid is quite noted for having large shooting stars, so you're still going to see them.
And they're very fast.